there has been a number of studies on the convergence of the negative integers. So far, there hasn't been any study that has illustrated or shown that the negative integers, they do converge to a particular integer. I have tried my best to also look at these negative integers and came up with these two rules that shows that all negative integers, they do converge to negative 1. So the rules are, you take any negative integer, if it is even, divide by 2. If it is odd, multiply by 3 and subtract 1. If the two rules are repeated on solutions, the sequence will converge to negative 1. I have the numerical proof, also extended numerical proof that helped me to come up with the formal proof. I've also reversed the sequence for the negative integers. Let us look at the numerical proof. We need to show here that negative integers really converge to negative 1 using these rules here. So negative 5 is odd. We are going to multiply this by negative by positive 3, and we subtract a 1. So negative, the first sequence, the first term in the sequence will be negative 5. Next one will be 3 times negative 5 minus 1. That will be negative 16. Now negative 16 is even. We divide by 2. That will be negative 8. And negative 8 is even. We divide by 2. Negative 4. We divide that by 2. Negative 2. We divide by negative 1. Then we move on to part B, where we have negative 12. So negative 12 will be the first integer. Then since it's even, we divide by 2, we get negative 6. This is even, we divide by negative, we divide by 2, we get negative 3, which is 4. Now multiply negative 3 by 3 and subtract a 1. So 3 times negative 3, negative 9 minus 1, negative 10. We have negative 10 here. This is given, we divide by 2, negative 5. Negative 5 will cut up all these terms which are here. So negative 5 multiplied by 3, subtract 1, negative 16. This is given, we will have negative 8, this is given, we have negative 4. And that is given, we have negative 2, and the final we have negative 1. So, using negative integers with these rules, the sequence is expected to converge at negative 1. This can also be proven by, first of all, looking at extended numerical proof. The proof that I've given for this also relied on the extended numerical proof, like for positive integers as well, which all converges to positive 1. So let's look at how we can also show that using the extended proof that the sequence can converge to negative 1. So I'll give an example here. Using the extended numerical proof, show that we can take any integer. In this case, we can pick on the negative 10. Show that negative sequence, the first integer in the sequence x1 will be equal to negative 10. Now this negative 10, it is uneven. We need to express it in a different form. In this case, my negative 10 can also be expressed as I have a, based on the extended numerical proof for positive integers, we borrow the idea. The coefficient here is 1, so I will add a 1, I will have a 2, then negative 10. Then my b here is 0, I will subtract that 0 minus a. So plus 0 minus negative 10. And our result here becomes 2 negative 10. Then this gives me positive 10. If I multiply this and that, I will get negative 20 plus 10, I will get negative 10. So this is my first integer in this sequence. So x2, I need to divide this even by 2. So our 2 negative 10 plus 10 divided by 2. The result will be negative 10, then plus 5. Negative 10 plus 5 is in fact odd. We need to multiply it by 3 and subtract a 1. So x3 is equal to 3 multiplied with negative 10 plus 5, then minus a 1. This will give us 3, open negative 10 close, then 3 times 5, that is 15, 15 minus 1, 14, our plus 14 here. If you look at that, this is an odd, this is an even integer here, because we have gotten it from the multiplication of 3 by an odd, then subtract 1. So the result is even. Unfortunately, 3 cannot be divided by 2. We need to add the 1 to this, and it becomes 4, then negative 10. Then we need to subtract the negative 10 from 14. That will give us positive 24. That will be used to find the next 10 in the sequence. So our x4 will be equal to 4 negative 10 plus 24 divided by 2. This will be 2 negative 10 plus 12. Then x5 will be equal to, divide that again by 2. This will be equal to negative 10 plus 6. Now negative 10 plus 6 is also, if we check this one, this is uneven as well. Now because it's uneven, it cannot be exactly divisible by 2 in the sense that the coefficient here is 1. So this will be equal to, we add 1 to the one that is here. This is 2 negative 10. Then 6 minus negative 20, 6 minus negative 10, that is positive 16. Then we can divide that by 2, and that gives us negative 10 plus 8. Negative 10 plus 8, that is also even. We need to express it in a form which will be exactly divisible by 2. So here I'll add 1 plus 1, that will be 2, negative 10, 8 minus negative 10, that is negative 18, positive 18. Then my x7 will be equal to the division of this, plus divided by 2, the result becomes negative 10 plus 9. So negative 10 plus 9, that is negative 1. Meaning that the sequence has converged to negative 1. Now, one interesting thing is that the convergence of the negative integers occurs at x plus z equals negative 1, where z is equal to, where our z is in fact where our z is in fact equal to negative 1 minus that is our x. That is the termination of the sequence. It occurs at x plus z equals negative 1, where our z is equal to negative 1 minus, sorry for that, this is supposed to be negative x